Hi everyone, my name is Parth and I'm back with another video on .NET. This video talks about exception handling in .NET. So let's begin. The topics which we would be covering in exception handling will include what do we mean by exception, how do we handle exceptions, what are the different types of exceptions, what are some common .NET exceptions we encounter in our daily life while programming. Then we'll talk about the three blocks of exceptions: try block, followed by catch block, followed by finally block. Then we'll have a glimpse of System.Exception class. Then we'll see some benefits of using exceptions, some keywords related to them, and a simple example. So let's begin with what is an exception. So an exception, you can say, is an event or a trigger which causes an error which occurs during the execution of a program. Basically, suppose let's say we have a program and it is executing some logic. In between that execution, there is some error occurred. So that error which occurs throws an exception basically. So an exception basically disturbs the normal flow of the program's execution. And exception handling basically, which is we'll be discussing in detail in future, it enables programmers to remove those error handling code from the main line of the program's execution. So basically, when we use exception handling, it tells us that on which line we have got the exception during the execution of a program. And it basically allows the problematic situations to be processed at multiple levels. So suppose we have a program and there are some errors or exceptions being thrown. So using exception handling, we can process that at multiple levels. Next is handling exceptions. So handling exceptions in layman terms means catching and processing the errors which we get during the execution of a program. In .NET, the exceptions are handled by try, catch, finally blocks, which we'll see in detail. All the exceptions are being provided by System.Exception class, which is the base class, or you can say the parent class for all kind of exceptions in .NET. Catch blocks can be used multiple times to process different exception types. Basically, we'll see about try catch block in detail, but for now, you can understand that catch blocks can be used multiple times, which means we can use multiple catch blocks in a single program to process or to handle, or we can catch different exception types in the execution of a program. So this is the basic syntax how we handle exceptions. So first is the try block. So basically it includes code in which exception occurs during the normal flow or execution of a program. Next is the catch block. So as you can see here, we have multiple catch blocks. So the first catch blocks basically talks about if there is some invalid operation which occurred. So for that we have catch block of invalid operation exception. Then we have a catch block if some other exception occurs apart from invalid operation. Finally, we have a generic catch block, which can basically handle any kind of exception which occur in the execution of our program. And here we use throw keyword to throw an exception. Finally, we have a finally block, which is basically not to be used mandatory, but yes, it gets executed whether or not there is an exception occurred or not in the execution of a program. And you can put some code here, although it's optional, but the code which is present in the finally block would always be executed regardless of whether the exception has occurred or not. Next is types of exceptions. So as I mentioned earlier, System.Exception is the parent class. Basically, we divide exceptions broadly into two types: system exception and application exception. So system exception means the exceptions which are inbuilt in the .NET framework. For example, argument exception, null reference exception, out of memory exception, and stack overflow exception, etc. And if we want to define a custom exception or a user defined exception, that in that case we use application exception class. Some of the common .NET exceptions are, like you can see, index out of range exception. So it occurs when you are trying to access the index of an array which is outside the range of that array. Then we have an index out of range exception that occurs during the execution of a program. Or if we are trying to use an you can say a variable or a reference which has a null value. So the exception class causes a null reference exception to us during the execution of that program. Let's talk about try block. So in the exception handling, first of all, and the foremost block which comes is the try block. So a try block basically contains the main code, the main logic of our program or application. It has the code which might throw an exception. It's not mandatory, but yes, if there is some exception occurs, that is during the execution which is happening in the try block. A try block must have at least one catch or finally block. So you cannot end your code by just completing a try block. It must have at least one catch or a finally block. Try block is followed by a catch block. So a catch block contains code which gets executed in response to an exception thrown by the try block. If the code in a try block doesn't cause an exception to be thrown, the CLR, or you can say the common language runtime, which is the runtime of .NET framework, will never execute the code in any of its catch blocks. The catch type must be of type System.Exception or a derived class of a System.Exception. The catch type means the type of exception. We can also specify a variable name, like you write catch keyword, in the bracket you write exception class, then you give a variable name, like you can see here, small e. So that also we can use to access information specific to the exception or to handle any kind of exception. Finally comes the finally block. So basically C# provides the finally block which executes always regardless of whether an exception occurs or not. So if there's a situation like we have an exception being thrown by the try block, the finally block executes after the catch block. But if there is a case that a try block has not thrown any exception, so the catch block will not execute, but the finally block will still execute. So this feature of finally blocks makes it ideal to write a code in which you want to release resources to free your connections which you have made in the corresponding try block. Let's talk about System.Exception class. So in .NET, only objects of class exception and its derived classes may be thrown and caught. In other words, that we mean that System.Exception is the parent class for all the kind of exceptions we encounter, be it system exceptions or application exceptions in our .NET framework. Exceptions thrown in other .NET languages can be caught with a general catch clause. So if we have some exception which is thrown in some other .NET language, for that we can use a general catch block. Class exception, as we know, is the base class of the parent class for all the different kind of exceptions. A catch block can use a base class type to catch a hierarchy of related exceptions. And a catch block that specifies a parameter of type exception can catch all exceptions, which means that if we want to we can say handle or catch any kind of exception, we can use the parent class. If you are not sure about what type of exception will be thrown, we can use the parent class, which is the exception class in our catch block. There are some benefits of using exceptions. That's why we use them in our code. So first is the ability to keep code that deals with exceptional situations in a central place. So basically we are maintaining a place or a log history, which is a central place to record all the exceptions that occur in a program or application. It also gives us a benefit to locate and fix bugs in the code. As we talk about old .NET frameworks which had Win32 APIs and COM components that returned a 32-bit error code. And if we use exceptions, then we can see the string description associated to that 32-bit error code, which is easier to read for the programmer and understand. Exceptions also include a stack trace, basically, that tells you the path the application took until the error has occurred in the execution of a program or application. Also, we have the liberty to put any kind of information you want in a user-defined exception, for which we use the application exception class. There are some keywords which are related to exceptions. Let's see them one by one. So first is help link. This is basically a string property of the exceptions. So this is basically empty because it is not defined on the exception. Second is message. This is a read-only string property and gives us a short description of the exception's cause. Third is the source. Source is a string property that can be assigned to or read from. So this basically gives us the application name from which the exception has occurred. Next is a very important stack trace. This is the path through the compiled program's method hierarchy that the exception was generated from. So it gives us the path until the exception has occurred in the program. Next is the target site. So this property basically gives us the name of the method where the error occurred. Like it can be a page load event or a private function. So basically this property helps simplify what part of the errors are recorded. Finally, let's see a simple example of exception handling. So you can see we have a page load event. It's a simple ASPX page. We're using try and catch block. In the try block, we are trying to divide 1 by 0. So you know if 1 is divided by 0, it becomes infinity. So we are trying to divide a number by 0. It will give us an exception. In the catch block, we're using the exception class, as you can see, and a variable with the name EX. And then we are printing the help link, message, source, stack trace, and target site. So you can see when this line inside try block executes, it gives us a divide by 0 exception. So you can see in the output, the message is attempted to divide by 0, means a short description of the exception or of the type of exception being thrown. Then is the source followed by stack trace. So you can see in the stack trace, it's giving us the path. As you can see here, the path is C users izone desktop.net project exception underscore sample default.aspx.cs. And it's also giving us the line number. And the target site basically gives us the name of the event or the method inside which the exception has thrown. In this case, it is page load event. So thank you very much. I hope you have got a basic understanding about exception handling in .NET. I will see you in some next topic very soon. Thank you.